So we've already learned about weak acids, and now we want to take a look at weak bases. The same idea applies to bases as to acids, and that is that a strong base in solution will completely dissociate. So every molecule or formula unit of the base that you put in will produce one hydroxide ion, and you're going to end up with no undissociated base left. Now, with a weak base, though, it's not going to work that way. So this is going to look a whole lot like the acids. I'm going to start with this kind of base because some of the weak bases have that formula. Some of them have a hydroxide ion built right into them, just like the strong bases do. And if they do, they're probably solids. And that's going to form in water something that looks like that. So quite analogous to what we did with the acids. All we're doing is breaking this up. But more commonly, the weak bases don't have a hydroxide ion built right into them. More commonly, these are something like this. And right now, all I've done is put the unshared pair of electrons and 3 bonds, and I've not shown you what it's bonded to. So let's start with the simplest case and just put hydrogens here. So this becomes ammonia. And in this case, the ammonia is actually going to react with the water. Now remember, our definition for a base is it's something that increases the amount of hydroxide ion in the water. So we know right away that one of the products for this reaction has to be a hydroxide ion, just like up here. Because if that didn't happen, it wouldn't be a base, and we're being told that this is a weak base. So I'm just going to put that down right to begin with. Well, the hydroxide ion obviously did not come from here. We don't have any oxygens over here. The hydroxide ion came from the water. So I'm just going to do a little trick here. Instead of writing H2O, I'm going to write HOH, because that's what water is. So this hydroxide ion is what got set loose, so to speak. And that happened because this hydrogen ion decided to come over here and bond to the nitrogen, and instead of sharing an electron that it came with, it's just going to share the 2 electrons that nitrogen has. So this is kind of an interesting scenario. When we think of sharing, we usually think of each party brings 1 electron and they share and they make this bond. But in this case, nitrogen is contributing both of the electrons. Hydrogen comes over without any electron at all, but they still share and they make a bond. So that shared pair of electrons is this pair of electrons. So this hydrogen comes right over there. So what we actually get here is NH4 positive, and again, that's going to be aqueous. So that's what's in solution. So what this really is ammonium hydroxide in solution, but when it's in water, it's broken up into these 2 parts that are not connected to each other anymore. They're separate in water. So that's a little bit more difficult to write because you have to think about it. But once you understand how this works, every one of the nitrogenous bases, that's what we call them, every one of the bases that's got a nitrogen in it is going to work the exact same way. And some of them are going to look like big scary molecules because they have lots of parts to them. But you can ignore all the parts except the nitrogen. That's all you care about. So let's try something else. I'm going to give you a really big scary one. And say that we're going to have this nitrogen, and it's going to have CH2CH3 over here, and it'll have a CH3 over here, and then it'll have a CH2CH2CH3 over there. And if you were to just look at this, especially if it were not written out like this, so this might be written something like this: nitrogen, and then it would be CH3CH2CH2, and then it would be CH3, and then you might have CH2CH3. So you would look at that and you would say, oh my gosh, I'm so confused. But don't be. Because it totally doesn't matter what all this stuff is. It doesn't matter what's attached to the nitrogen. The only thing you have to focus on is, oh, there's a nitrogen there. And as soon as you see that nitrogen with this unshared pair of electrons, you know what it's going to do when it gets into water. Just ignore this stuff. Doesn't matter. So let's add water to this because that's what happens. And you'll notice that most of the time when we were doing those reactions with acid, we know that this is happening because it goes into water, but we don't have to show the water molecule. But in this case, we have to show the water molecule. So again, we think of this as HOH. We know it's a base and it's putting hydroxide ions into solution. And what else is it going to put into solution? Well, it's going to put this whole big thing into solution with the attached hydrogen that came off the water. So over here, kind of running out of room, but that's all right. So we'll write CH3, CH2, CH2, N, and then we'll attach an H up there, and then we'll just copy the other stuff. So all this is a little copying exercise, except that you're going to take one of these hydrogens and add it to the nitrogen. Then we just stick our positive sign in there somewhere. It doesn't really matter too much where you put it. And ta-da, there you have it. So that's the other product. So this is one of those things that can look as if it's going to be really confusing and hard to do. But once you see what's going on, you don't have to worry about the fact that these molecules are big and unfamiliar. You just have to focus on the fact that this nitrogen is going to grab a hydrogen off the water, and that's going to leave a free hydroxide in solution. Probably need a plus sign here. And that's going to give us a product that's exactly the same as this, except we stuck an extra hydrogen on it.